Okay, so I believe, did you have some problems in your homework where you had to multiply complex numbers in standard form and then you changed them to trigonometric form and multiplied them? You had some problems like that, correct? Okay. Let me ask you this. Did you feel that it was more work to change them into trig form and then multiply them and then change them back?
Yes.
Okay. What about dividing? Which way was faster? Which way? Okay. Maybe it's a wash, okay? But if I give you a complex number in standard form, and you have to change them, and then do the operation, and then change them back, okay, that could get, you may not feel that that's 100% always worth it, okay? Now, what if I gave you, oh, I'm frozen. Okay. Don't write this down, but if I gave you 1 plus 2i to the 5th power, what would you have to do? Yeah, you're going to have to multiply 4 times. Okay? That doesn't sound like a lot of fun, does it? Yes, you're gonna have a lot of like i's to a power that you're then gonna have to reduce down. And so if you remember the triangle, yes. Okay. But it's gonna be a lot of work. So I would like to talk about how to take powers of a complex number. Okay. So you're gonna help me find a pattern. Are you ready? Here I just have a general complex number. Okay, we know how to multiply these, correct? So when I take z squared, do you agree that that's the same as z times z? Yes, thank you. All right, so when we multiply, we have to take r times r, so that would give us r squared, right? And then we add our angles together. Well, what's theta plus theta? All right. Okay. Let's talk about z cubed. Do you agree that z cubed would be the same thing as z times z squared? And because we know z squared and we know z. Okay. So if we're taking z times z squared, then we know we multiply our r. So what's r times r squared? R cubed. We know we have to add our angles. Z has an angle of theta. Z squared has an angle of 2 theta. We add them to get 3 theta. Are we noticing a pattern? Yes. So let's take that pattern. All right. If I'm taking z to the 4th, what's going to happen to my r value? It's going to go to the 4th power. And what's going to happen to my theta value? It's going to be 4 theta. Okay, so do you notice how the r value gets the power? And then as we add the thetas together, right, as we keep adding, it's really just that theta getting multiplied by the power, right? So let me introduce you to de Moivre's theorem. Okay, write down what's in red. De Moivre's theorem is this in red. It's what you just figured out on the slide previous.
Extra for labor. I'm gonna tell him somebody's gonna buy it.
Now, I don't think this is going to happen to you very often, but if you are leaving it in trig form, it is important to reduce that angle all the way between 0 and 360, just like we did with multiplying and dividing. Okay? Now, when you're multiplying by a number, it's possible that we would have to subtract 360 more than once to get back down to an appropriate angle. Okay? All right. So we really only need one example of this, okay? We are going to take -1 plus radical 3i to the 12th power. I want you to imagine if we did not know trigonometric complex numbers, I want you to imagine doing this problem. Richard says, no, thank you. Okay, it does not sound fun, does it? Okay, so Caleb, when you were asking me the other day about like why do you need to know this? Okay, here is like the greatest example I can show you on why this is helpful. Look, we're taking this to the 12th power. No thank you.
Real life, like a job interview for McDonald's, like.
Okay, probably not. Probably not. You don't. There's a lot that you don't know you'll need until you'll get there, and the things that I'd actually talk about aren't going to make sense to you right now. Okay? So let's put this into trig form. Are you ready? All right. So let's first find the absolute value. So we have the square root of -1 squared plus radical 3 squared. What is that? 2. It is 2. Okay. Now let's talk about the angle. The tangent of theta is radical 3 over -1. Okay. I am hoping you don't need your calculator for this because it is a unit circle value. So some of you found it anyway. What's our reference angle? Our reference angle is 60. And you know what? You have your calculator, so if you use it, like, no big deal. Okay? Our reference angle is 60 degrees. However, our angle is not 60 degrees because we're not in the first quadrant. Think about the quadrant we're in. Think, don't say. Now think about if our reference angle is 60, in that quadrant, what should our angle be? You're saying we're in the fourth quadrant? Okay. If we were to plot this number, -1 means we would go which direction? Left, and then radical 3? Up. Okay. Okay, so what's our angle? Good. Okay, so what we have is we have 2 CIS 120 raised to the 12th power. Okay, now help me out. What do we do with 2 and the 12? 12 gets to be the what for 2? 12 gets to be the power for 2. Okay? However, 120 gets multiplied to 12. Okay, so first job, I need to know what 2 to the 12th is. Whoa. Now I need to know what 120 times 12 is. What? Okay, So Eli is saying that you can subtract 360 multiple times and it gets you all the way down to 0. Is he correct? Yeah? How many times did it take? 4 times? Ooh. Fix that. Okay. So, first of all, we have an answer, right? We have a complex number. What form did I give you the problem in? Standard form, right? So we need to get it back to standard form. If I give you an operation to do, either I'm going to ask you for a specific form or you're just going to give it to me in the same form that it was in the first place. So that's not a big deal. This just means 4,096 cosine of 0 plus I times 4,096 sine of 0. What's the cosine of 0? 1. And what's the sine of 0? Okay, 4,096. We actually say that we would say that negative 1 plus radical 3i is actually a 12th root of 4,096. Because when you take that number to the 12th power, you get 4,096. Well, the sine of 0 is 0. So when we take 0 times 496, it goes to 0, so then we don't have to write the I. Okay? Okay, isn't that crazy? So we can take a number to a power, or a complex number to a power, and then get it over. Okay, so that's going to lead me into what we talk about next. Okay? We are going to find roots of complex numbers. Now, you have found roots before. Okay? What are the roots of 4? Okay? If you had x squared equals 4, and you square root both sides, what are the square roots of 4? Plus or minus 2, right? Okay. Well, when you have like x cubed equals 8, and you take the cubed root of both sides, what answer do you give me? There's 2. There's actually 2 more roots. Okay? There is just as many roots as what you are finding. So there are always going to be square roots of a number. There's always going to be 2 of them. There's always going to be 3 cubed roots of a number. There's always going to be 4 fourth roots of a number. But what you don't know is that some of them are complex. Like some of them are imaginary. Okay? You get some real ones, but then you also get some complex ones as well. So just take a moment and write this down. It's not going to make sense right now. Just write it down. There's no sense in me talking about it until you have it written down. You don't have to memorize this. This will be given to you on the test.
You have the time to like make this one. Like, do they have a life? You love it. You love it. You love it. No, you know you love it. No.
Okay. So first of all, whatever root you're finding, there's going to be that many of them. Okay? So if you're finding fourth roots, you're going to have 4 of them. If you're finding third roots, there's going to be 3 of them, etc. And that's what that N stands for. If you're finding fifth roots, then N is 5. If you're finding third roots, N is 3. Okay? So then what's going to happen as you use this formula, okay, you're always going to start with 0 in here for K. All right? And then you're going to get an answer. And then for your next root, you're going to put K is 1. And then you're going to get an answer. And then for your next root, you're going to put in K is 2. All right? And then you're going to stop when you have as many that you need. Okay? So if you're finding third roots, you're going to plug 0 in, get an answer, plug 1 in, get an answer, plug 2 in, get an answer. Okay? Now, some of you maybe like working in radians, maybe some of you like working in degrees, or maybe I give you a problem that has a degree measurement. So if you're going to use a degrees, instead of 2 pi, you would put 360, okay? And that can be up to you, but you know that 2 pi and 360 degrees, they mean the same thing. So you can use them interchangeably. Chris, did you have a question or did I answer? You were stretching. Then you go. Okay. So the first example we are going to do, we are going to find the square roots of this number. And I go ahead and give it to you in trig form. Okay, so how many are we actually going to find? 2. We're going to find 2 of them. So first of all, since it's square roots and is 2, we're going to start out with K equals 1, and then we're going to use K equals 0. We always start with K equals 0. We'll plug in K equals 1, and then we'll have 2 roots. That's all we need. Okay. So let's follow this formula. Nth root of r. Well, if r is 16, we're taking square roots. We just have to take the square root of 16. Okay. Our angle is 60 degrees. So we're going to take our angle plus 0 over n is 2. Okay. I like to save room. All right. So instead of writing this all out and then reducing that fraction in another step, we know these two angles are the same. What's 60 plus 0 divided by 2? 30 degrees. Okay. I'm going to go ahead and ask that for this particular problem, we go all the way to standard form. Okay. And you'll see why I'm having you do this here in a moment. Okay. If it were just in trig form, then we would have, what, 4 cosine of 30 degrees plus I sine of 30 degrees. Okay? That would be our trig form. In standard form, we know that the cosine of 30 is radical 3 over 2. And we know that the sine of 30 is 1/2. So there would be 1 square root. Yes?
So like the square root of 16 would be plus or minus 4?
No. We only do that when we're solving and needing to get all of the real possibilities. I forgot to write it. Thank you, Eli. Okay. So then what we're going to do this again, but now with k is 1. So we're going to take square root of 16 times the cosine of 60 degrees plus 360 times 1 over 3. What would that be? Over 2. Come on, Mrs. Woman. Over 2.
I don't know.
210? Okay. So in trig form, our root is 4 cosine of 210 plus I sine of 210. Since the cosine of 210 is negative radical 3 over 2, and the sine of 210 is negative 1/2, this would be the standard form of our root. Okay, so let's just talk about what we found. Up here, we have 16 times 1/2 is 8. Okay, in standard form, this is the number that we started with. And when we found our square roots, we got 2 radical 3 plus 2i and negative 2 radical 3 minus 2i. What does that mean? That means if we square these two numbers individually, we get back to this number up here. Because these are the square roots. Yes?
Does it still apply that like the I factors from pairs? I remember last
No.
week.
Oh,
Yeah. Like if you have
they're not going to come in. Not necessarily. There's going to be some patterns, but not necessarily every time. Are they going to be exactly conjugates? Okay, I'm going to have to, because if we have fifth roots, it's not going to be, we're not going to have that symmetry. Okay. Now, how far apart were these angles right here? How far apart are these angles right here? 180. Okay. We're going to find all the sixth roots of mystery number 1. And we have 10 minutes left. I'm not sure if we'll get to all 6 of them. Now, tell me what you know. I'm asking you to find numbers that when we take them to the 6th power, we get 1. Do you know any? 1. Yes. You know? Yes. Negative 1. Okay, so we know 2 of the 6, right? We know 1 squared, 1 to the 6th and negative 1 to the 6th would get us 1. Yes. Okay. Now, we need this in trig form. Okay, what's the absolute value of 1?
Wait a second.
Okay, it's 1. And what would our angle be? 1 is right here on just the real axis. What's our angle? 0. All right, let's get started. K equals 0. We have the 6th root of r times the cosine of our angle plus 360k over n. So theta plus 360k, k is 0, over n. Cool, what's our angle? Okay. our angle is 0. So we have 1 times the cosine of 0 plus 1 times the sine of 0i. There you go, Nick. There is the root that you told me. Yay! On to the next one. Okay. Now we're going to do k is 1. So we still have the nth root of r, but now we need to take theta plus 360k over n. Help me out. What is that? What? 60. So we have 1 times the cosine of 60 plus 1 times the sine of 60i. If you take this number to the 6th power, you'll get 1. Now what's nice about this is you are going to see some patterns. All right? So let's see what happens with this next one. When k is 2, we're going to get the 6th root of n, excuse me, the nth root of r, so the 6th root of 1. Our angle is going to be theta now plus 360 times 2 divided by n, which is 6. What angle is that? 120. So we went from 0 to 60 to 120. Do you notice something? They're all how far apart? 60 degrees. So guess what? The next 3 are also going to be 60 degrees apart. Okay? What happens is we take 360 degrees and we evenly divide it up between our roots. So when we had 2 roots, they were 180 degrees apart. Now that we have 6 roots, they're 60 degrees apart. If there were 3 roots, they would be 120 degrees apart. Okay? Now, whether you pick up on that or not, I don't care. You can use the formula and plug and chug as much as you want to. But I am telling you right now, there will be symmetry. Okay? So if we go ahead and evaluate this, the cosine of 120 is negative 1/2, and the sine of 120 is positive radical 3 over 2. Okay? So this is what you can do. Now for k equals 3, instead of actually like figuring out what the angle is using the formula, I know that these have all been 60 degrees apart, so my next angle is 180. What's the cosine of 180? Negative 1. Hey, Chris, here's the root that you told me. Because the sine of 80 is 0. Is that you?
What? I did not write that. I did it. That's not I even know.
Okay. We also know the next couple are going to be, was that you? Since these are all 60 degrees apart, our next angle would be 240. Okay. So the cosine of 240 would be negative 1/2. And the sine of 240 would be negative radical 3 over 2. And then times your I. Okay? All right. right, and then our last root, right, we need 6. This is number 6. Since these are all 60 degrees apart, this is going to be angle 300. So we get positive 1/2 minus radical 3 over 2 pi. Now, somebody asked me that conjugate question. Yeah, you do see conjugates here, don't you? But that's because we have a nice symmetry, okay? Like I said, if we had,
Yeah, like they are. Yeah.
well, yeah, what's 360 divided by 8? Okay, so if you had 8 roots, all of your angles would be 45 degrees apart. See what I mean? Okay. Okay, now, yes.
Why would we need to know the factors if they're imaginary?
Well, I mean, this can,
When do you when is it practical?
not in the recent future, but depending on what you decide to go do, okay? Don't cut out all your possibilities. Okay, now, this may or may not be one of the, especially this root, your problems have been very short recently, yeah? They've been very short and quick. These ones are not. Your homework assignment has less problems tonight, but it's very important that you do them, because guess what? Since this problem has so much work, what does that mean about that problem on the test? It's going to be worth more points. So if you cannot do this on the test, you're missing a good chunk of points, okay? I just want to be very upfront with you about that. So you need to know how to do this. Like I said, I'm going to give you the formula, but you still got to know how to use it and find everything, okay? Okay, so homework tonight, activity about you.